Okay, so this is going to be an island viewer tutorial on how to find the pathogenicity islands for Staphylococcus MRSA. So the first thing we want to do is find the genome. Let's see if this is going to load. Okay, so we're going to go to the genome, and this is going to pull in basically the entire circular genome for the bacteria and some other information as well. So the first thing we want to look at is one, the presence of a lot of different things marked on the genome. Um, One thing that's important to note is the prediction method. So these are basically how they've come about identifying genomic islands by using these different programs, basically, that annotate certain parts of the genome with just basically this blue mark saying, okay, this program, Island Path DIMOB, was able to identify certain genomic islands for this bacteria. And one thing that's important is genomic islands don't exactly mean pathogenicity islands. Genomic islands are basically what allows the bacteria or pathogen to um, exist under certain environmental conditions. So it doesn't exactly mean what makes the bacteria pathogenic. But here in this table, we can you can look at all of the genes in this little slice, but the ones marked in blue is what island path DMOB has marked as a genomic island. And if you click, it will take you to the NCBI page if it wants to load, where you can look at more information about the gene. Um, well, this exact one is no longer suppressed. But if you go to another one, we can see more information about the gene. Links, FOSTA, whatever. So that's one thing that's important, but that's simply what is a genomic island. So if we want to look at virulence factors, resistant genes, which would indicate pathogenicity, um, that's where you would go more in depth in the genome. So for example, if we want, we can move this little slice so that we can get to an area. Let's see. Oops. Here's fine. So here we have some more parts marked with the prediction methods, but we want to look at, for example, this long purple marked area down here. You could also view this entire area down here, but marked in purple, oops, we have all of these, which dark purple is the virulence factors for this bacteria. Light purple is the homologs, which you can use to insinuate, like, okay, maybe this is an area of pathogenicity. So, for example, a lot of these are capsular polysaccharide biosynthesis protein, and with a little more research, you'll find that capsular polysaccharide proteins are virulence factors, and they have a mechanism that allows the bacteria or pathogen to be more pathogenic. I'm not going to go too much in depth in those, but if you click on them, they'll take you to the NCBI page, and you can see that they even marked it with the database where they found the bacterial virulence factor and more information about that gene. So you could assume this is an area, maybe a pathogenicity island, given the vast amount of virulence factors, but anywhere along the genome you can go and click and you'll be able to find, you could just move this down and you can literally look at the entire genome. Oops. And you can find more instances where we have some proteins that may contribute to virulence slash pathogenicity. So you can also look down here. These are predicted genomic islands, and the ones marked some external annotations, resistant gene, resistant gene. So if you go here, and that takes you, you can just open up this little chart again, and that basically brings you to that site right here and lists the genes and products. There's certain types of proteins, and we know, like for example, transposases are associated with um, pathogenicity. So that's one area. Another way you can type in visualize. Okay, so we want to visualize two genomes. We just click this, and I believe we put MSA, and it was this one. So when we do that, let's see, display genome. So this is both strains put side to side. We have MRSA, which is methicillin resistant, and then we have MSSA, which is methicillin sensitive. So by having these two genomes here, you can identify what parts of the genome contribute to resistance on MRSA, what parts of the genome that MSSA is missing. So for example, in this one region I just highlighted, and you can go in and look at it. I believe if we look over here, or maybe, yeah, we can see some resistant genes on MRSA that contribute to its resistance to beta-lactams, which are antibiotics like methicillin, penicillin, stuff like those. You can see that we have these genes listed here. You can go in and look at what these proteins do. Beta-lactam resistant, so this contributes to its antibiotic resistance. And then if we look over here, so this is kind of the same region. We have bases like 46,000, and this is where we found the beta-lactam gene, the antibiotic resistant gene. This is, like 46 to 48. If we go back over here and we zoom in a little bit, we can see that that's missing, that gene. So that's probably something that contributes to MRSA being MRSA. And you can probably find more along the entire genome. For example, this region here is not located over here, but these are the same regions. And yeah, you could also go down and see that there is much more predictions for the genomic islands on MRSA than SSA. And yeah, it's a pretty interesting tool to visualize. You can see some things remain the same about the pathogen, and some things are different, but there's far less on MSSA. And yeah.